Hey there, we're Miller, a consultancy that helps teams and companies to adopt Rust in their engineering organizations. And we're also a new group of contributors to the Rustacean Station community podcast. We're going to be releasing a number of interviews with great authors and people using Rust professionally over the coming month. You can also find a link to the video of the conversation in the show notes. Enjoy! I'm Marco Otte-Witte. I'm the founder of Matter, and I'm joined today by Stefan Baumgartner, who is a senior product architect at Dynatrace and a long-time independent trainer with hundreds of workshops probably over the years on various topics, including Rust. Hi, Stefan.
Hi, Marco.
Thanks for joining today, and I'm looking forward to the conversation. Could you maybe introduce yourself a bit?
You already did a great introduction. I'm Stefan. I work as a senior product architect at Dynatrace, which means that I take technical ownership and leadership in certain parts of our product. And in that role, I've been working with Rust now professionally for over 3 years, using Rust in various bits and pieces in our product, which is interesting. We are additionally a Java shop. So Java was the platform we grew up on, which nurtured Dynatrace. And, in recent years, several other technologies found their way into our platform. And with that, also Rust.
I think that's sort of the first aspect also that I would like to focus on before we move on to your training business and sort of to experience teaching people Rust. I think it's something sort of that many people would like to do, but don't succeed necessarily, which is sort of introducing Rust in their whatever sized company, replacing something else, right? Like in your case, replacing or augmenting something existing like Java, right? Could you share some details, sort of where you're using Rust, also maybe how you managed to convince management to be open to accepting a new technology like Rust?
Yeah, so I think the size of the company plays a big role in the decision of which technology you choose. You either are very small, which allows you to make fast decisions and people are just trying out things and are happy with it, or you're so big that all your technical decisions are just not seen by upper management, so you can go and run with them. And then you have this big field in between where you decided on a set of technologies for good reason, because people are productive in it, you have all the processes set up, you don't lose time with all the setup and infrastructure that a new technology brings along. And if you reach that size, and that's a very broad field, you need to ask yourself, am I using the right tool for the job? So this is always the questions that you need to ask yourself. And thankfully, the Rust is a tool that is the right tool for many jobs, as it turned out. So I used it originally to write some command line applications. But then when we had a very particular issue regarding our serverless backend infrastructure, so I'm working on a project called App Engine, which is an extension of the Dynatrace platform that allows customers, partners, and ourselves to produce new content for the Dynatrace product.
Maybe you can give a high-level explanation of what Dynatrace is and does for the people who don't know. I'm sure most people know, but
the Dynatrace platform is an application monitoring product, which means that we inject our agents in your software and collect telemetry so you know better what your product is about and how product behaves. And we allow our clients and our partners to extend the platform with their own use cases, with their own what we call apps, and allow them to run JavaScript workloads in the backend, which means that we open up all our sensitive data to our clients' self-written code, which has lots of security implications, obviously. And this is where we reached out to Rust, because with Rust we had the possibility to write a server-side JavaScript runtime that follows our rules, that follows our security implications. And with Rust, it was just taking this particular crate, this particular library, and your idea, putting it together, and you had a first working prototype within a couple of days. And this was something, especially at the size of Dynatrace where we are right now, I haven't experienced in years. That we were able to take a new technology and tackle one particular use case that would have taken ages to develop in any other technology, be it Java, Go, you name it, doesn't matter. Getting a functioning prototype done within a couple of days, that was just tremendous. And this early strains of this prototype, of this POC, still run today. So we just developed upon the original proof of concept, continued working there, and were able to ship really fast a really great working product, where we haven't experienced that many issues or bugs. So not only did we have the chance to take something entirely new that wouldn't have been done so quickly in any other technology, but a very small team of, let's say, 4 or 5 people right now were able to maintain this key part of our product with ease. So no major outages, no major bugs, everything running as we intended it to run. Of course, you can have logic bugs, but overall, it's one of our most stable pieces in the new platform, and one of the best experiences that we had in recent years.
I think the second part of your answer there, sort of the stability, right? Sort of this thing just running, sort of then being like no or few bugs only. I think that's kind of what people expect from Rust, right? Sort of it's gonna be stable and so on. I think the first part of your answer is maybe a bit surprising though, right? Where you say sort of it was actually a great tool for prototyping this and building a first version fast, right? Where typically your expectation would be like first version takes forever, but then it's going to be stable and fast, right? Yeah, maybe you can share some thoughts about sort of why prototyping worked so well, and does that maybe prove the ecosystem being much more mature than people think, maybe?
You are saying a very correct thing, because Rust is usually known for its very steep learning curve and people needing a lot of time to get going, and the Rust compiler constantly complaining about your work and you need to adjust. And all those things are kind of true, but it depends from which angle you approach it. So we had some prior Rust experience. I've written a couple of CLI applications. My colleague also has written a couple of microservices in Rust. So we knew our way around in Rust, but we didn't create something that you would really call production-grade software. But when you experience a little bit of prior knowledge and you jump over the initial hurdles, then you can create new software rather quickly. If you know your way around, if you know which crates to use, if you know the ecosystem around it, and if you know what to expect from the Rust compiler. If you engage in this dialogue between the Rust compiler and yourself, and you know what to expect, you know the questions it asks from you, you know the answers to that, you can get really, really far in prototyping, because the ecosystem is rich. So we were using a JavaScript runtime. The bindings that you have on Google's V8 are so much better than in C++. Where it originates from, because it's well documented. You know about all the implications on memory just from reading the interface. There's no need for you to dive into the nitty-gritty of the V8 implementation. You can just consume it. And the interface, the function signatures tell you what to expect, just because you know your way around the ownership model. This is so powerful. And so elevating that you really can get moving fast or can get started fast. In our case, it was like using these particular binaries, these particular libraries, using those particular crates. We didn't know our way around in V8, but Rust kind of guided us. Rust kind of told us what to expect, and we were just following along. We had a goal, and we were able to follow it along, because of the crates we were using, because of the libraries that we were using, and because of the compiler telling us what to expect. And with that, so I remember it vividly. I was at the garage changing tires and had 2 hours of time, just flipping out the laptop, installing a crate, trying to get some Hello World example running, and there it was. That was our POC. Attach it to AWS Lambda, then you're done. Fantastic. It took me 2 hours. I sent the files over to my colleague, and then we started hacking again. So that's possible. That's possible. You need to accept the initial dialogue. You need to unlearn a lot of things, I guess, from previous programming languages, and accept a new way of programming with a compiler. And if you can get over this initial hurdle, then a whole area of opportunities open up to you.
What would you say sort of were the specific benefits you got out of writing that particular service in Rust as opposed to like Java, which you would have normally used?
One thing is definitely stability. So with Rust, we were able to write much, much more stable software, especially given the small team size that we have. So it's just, at the time, it was just 3 or 4 developers. And they were rarely confronted with maintenance work or bug fixing or something like that, which allowed them to actually work on features, to work on items from the roadmap rather than reserve, 20-30% of the time just to fix stuff. That's one thing. And the other thing definitely is that we are attaching V8 to our own software, and V8 is written in C++. We found it much harder to find good bindings to V8 in other programming languages. If we would have written it in C++, we found it hard to find C++ developers who can handle V8, who can write stable software on top of V8 in C++, in that amount of time that we needed, that we were given to produce a finished product. And with Rust, we had, the support from the compiler and the maturity of the ecosystem. The Rust bindings from V8 are so good and so mature and so telling that it allowed us to create a sound product that is shippable, that passes all our quality gates within a few weeks, without any hiccup whatsoever. And this is something that I guess we don't talk too often about, is that Rust has already a really, really good ecosystem. The maturity is at times outstanding and much better than in any other programming language. And if you look at things like, for example, Tokyo or the Hyper implementation, which also feature things like AWS Firecracker, the micro VM technology that powers Lambda and Fargate. That stuff, millions of people and millions of compute hours a day rely on, and they work, they are stable, they are mature in a quality that you don't see in any other ecosystem. Especially, so I usually compare Node.js and Rust, and documentation in Rust, examples that you find for Rust open source projects is just so much better and so much more complete than you find it in Node.
The maturity of the ecosystem, which is sort of much more mature in many ways than others, right? Obviously, specifically more lower level things, right? But I would maybe say comparing to Node is a bit unfair, though, because Node is also famously immature. It's just huge, right? It's kind of.
So I don't want to pick on Node too much, because I honestly have a soft spot for Node. I love what they are doing, and it has been very influential for my work. But you can't say that the ecosystem is mature. It's vast, it's rich, it's the biggest in programming history, but maturity is a different topic.
Yeah. I think for many people sort of stuck in the JavaScript world, sort of Rust can also be sort of an escape route to something more mature. And
definitely. So it was for me. So I looked specifically in Rust for trying to go off the old and beaten path and see how it is on the other side.
I think that kind of leads us already sort of to the second topic, right? Which is sort of learning Rust, and in your case also teaching Rust, right? Can you maybe talk a bit about sort of your personal experience, sort of where you were coming from in terms of previously used languages, and then how you got into Rust personally? Professionally,
I worked originally with Java, C, and C++, and a little bit of C#. So those were my early days back in the early 2000s, fresh from university, usually creating some Windows desktop applications in C# with some C++ image optimizing algorithms in the back. So having this interface between natively compiled binaries and some managed software in the front. And, that was fine. Everything was running. I always say, so there were a couple of installations that I wrote that are running at BMW. And they always say the guy at the end of the shift at BMW was my garbage collector because he was turning off the machines. And that's how I never got into any memory corruption problems, thankfully. But you can't afford this anymore, Right now, your software needs to run full time. I switched over to web development. Sheer out of interest, web development was fun. It was a little bit, if you've done strictly typed programming languages like Java and C#, writing JavaScript was like going to Woodstock for a couple of years, and you can do everything. Everybody expects you to do everything, which was a lot of fun. Lots of people made the same progress, I guess. They started out with those classical programming languages, Java, C#, then went into web development, seeing a totally new field there. And finally, lots of people now go back into I wouldn't say go back into something like compiled languages or natively compiled languages. I think they find some sort of renaissance, because with tools like the LLVM or with and programming languages like Go, Rust, Seek, you name it, it becomes really on vogue to write highly optimized programming code, highly optimized programs again. This is quite interesting because over the course of the last decades, every innovation in programming included some sort of letting go of memory management, letting go of the actual computing stuff underneath, like what is a stack, what is a heap, what does memory allocation mean, what does multi-threading mean? Especially if you look at the concurrency model in Go, it's just like, you have this one concurrency model. We don't tell you what's happening there. Just work with it. We are doing the best thing for you. Or JavaScript, where you say, okay, multi-threading, of course, just start two processes, then you have multi-threading. And we kind of forget all of that, and which leads to very interesting scenarios where, especially in JavaScript, the things that you do there by creating objects that point through, that can have circular references, that can have pointers to other objects, all back again, which are really heavy in terms of how memory is managed for those structures. All the developers tend to forget the underlying principles. Like there's some actual hardware underneath that needs to work with the stuff that you are doing. And this is something that I experience now when training people in Rust. We spend at least half a day in talking about this is what computers do. This is what you need to expect from a computer. This is what you need to expect from the data structures that you create. And this is how Rust as a language tells you what to expect. You can see which parts are on the stack. You can see which parts are on the heap. You can see when memory allocation takes place. You can see when deallocation takes place. You can do fantastic things in trying out filling an array with enums versus filling a vector with trade objects. It basically does the same thing, but the difference in performance is huge. It's orders of magnitude even at some point.
Yeah.
And this really gives you a really good feeling of what's happening in your software. And then you start thinking about every little piece of code that you write. You make decisions with every little piece of code that you write. And at one point in time, you say, "Oh, this is not something that is annoying or stopping me in any way. It's actually much more empowering. So I'm able to make all those decisions and have a compiler that guides me making those decisions." And in my opinion, this is the biggest aha moment when I teach Rust to other people. It's like, oh, so this is what happens, and this is how I can influence it. And people really find some sort of not only joy but even pride in making those kind of instructions and creating software that is fast, that is reliable, and that has and that you can influence with the style of programming that you take.
As a consequence, would you say that it's easier to teach people Rust, or for people to learn Rust who have done like C#, C++, Java, like typed languages before, than JavaScript, Ruby, Python, where sort of even the idea of memory management is completely alien to you because you don't care?
That's a very interesting question. I couldn't couldn't point to a difference in like, oh, you already worked with a strictly typed language and worked with, already knew a little bit about memory management because of your choice in programming language. I rather saw that people who have mostly worked in dynamic languages or scripted languages, that they might not have heard about certain terms, that those are totally new concepts for them, but they are much, much more open in learning them or see it with a very fresh eye. Whereas if you already worked in a language where you know a little bit about memory management, or if you've done C or C++, you don't need to learn those terms and the concepts underneath. You just need to learn a new way of dealing with them, which might be much, much, much harder than just, that's how programming works. Okay, now I can see what's happening there, and now I can try to figure my way around. So that's a very, very different approaches from different sides. But so one thing that all of them have in common is that it takes a while to accept that this is not the usual kind of programming they did. This is, no matter which programming language that you're coming from, everybody has the same experience. This is something that's new to me. This is something that where I need to unlearn things rather than learn.
And you're saying, at least in terms of memory management and so on, someone who did C++ has to unlearn more than someone who has done JavaScript before because they don't have any concept of memory management?
Yeah, exactly. So people in C and C++ need to unlearn a lot of things, whereas if you've never done any memory management in your life, it can be a quite interesting experience, but you go to it with a fresh eye.
And I mean, I think that's the case for many people, right? Even I did some C in university, learned memory management, but then it was like C#, JavaScript, Ruby. I never done any memory management or any language where that was even relevant, like my entire career almost, right? So I think it's sort of many people are coming back to that, as I said before, right? Sort of with that overall sort of renaissance of like typed languages and efficiency being relevant and so on, right? That nobody really cared about for like a long time, sort of like with like Rails becoming popular and JavaScript and so on. It was all focused on DX and simplicity more than efficiency, right?
Absolutely. So I've started university in 2000. I've done programming for 25 years, and nobody in all those 25 years told me that manual memory management and natively compiled binaries are the way to go. Usually you always go one level above and work with some sort of runtime that takes care of the heavy bits for you. And this is new for me. So this is, as you said, it's a renaissance. People are going back to languages where they can that allow them to do more, where they have much, much more flexibility, where they can express themselves better. And I think it needs a programming language like Rust that gives you additional guarantees like, wait, if it compiles, it works. Memory management is done for you if it compiles. And you still get those high-level primitives like iterators or the result type that allow you to work with a really nice API, that work with a really nice syntax even. It needs tools like that to make this renaissance happen. Nobody of us wants to go back to pointer arithmetics where you have, I don't know how many asterisks in front of your variable and then how many ampersands to dereference them. That's nobody wants to do that. It needs to be clear. It needs to tell you what's happening, but it also needs to be easy to use. And what I found, especially with Rust and especially with people learning Rust, there's this one point in time where you're not fighting the ownership model or the borrow check anymore, but where you adopted a programming style that aligns really, really, really well with what Rust expects you from memory management. And then you are really productive. Then you crank out programs within minutes, within hours. It doesn't matter. So you are really, really fast in developing your software. You rarely run into any problems that are related to memory management or where you didn't get the concepts quite right. The tools and the documentation are excellent. So if you run into a problem with the library authors really help you with lots of examples, lots of additional blogs, tutorials, books, whatever. This is something that I haven't seen in any other programming language. This willingness to share experience is outstanding in Rust.
Also, like you said before, sort of that key moment is kind of when you start realizing the compiler is sort of like a friend that guides you rather than sort of your enemy that like yells at you with like 5,000 line long error messages, right?
I mean, you have to be true, you can get those 5,000 lines error messages as well.
Yeah, for sure.
So I had those in a couple of asynchronous programs that rely on Tokio. But even there, if the programming errors are not that nice, or the compiler errors are not that nice, there are at least efforts to improve them. So I've been in contact with Stefan Baumgartner, who works for AWS on Rust, working explicitly on the compiler errors. And what I heard is that they are working on a way for libraries to inject error messages. If something goes wrong, they can tell you, wait, this is why it goes wrong, and what you can fix to make it work again, which is fantastic. So if I can influence compiler errors when using when I write the library, how great is that? That's the best way to get to your users and the best way to guide them through your code.
Let's get back to learning Rust and, like I said, in your case, teaching Rust. So obviously, for a lot, or for everyone really, because Rust is really different from like everything else, right? There's a lot to learn before, so like you can get into the flow, right? Borrow checker, lifetime, sort of all of these things that are unique to Rust, right? Is your approach to teaching Rust sort of first sort of like getting over these hard concepts, or do you have like a different approach where you don't have that sort of huge sort of wall between you and your future in Rust?
One thing that I found out is when teaching Rust is it's always better to give people who are learning Rust a concrete problem to work on, let be it a web application or be it a command line application, something where they can see results immediately and where they can work towards a goal. Because no matter which tool you're using or which tool you are writing, you will run into ownership problems at one point in time.
Yeah.
And this is then the place where you can hook in, teach them about the ownership concepts, give them ideas why this is happening, do some nice drawings here. Say this is how your tasks are distributed now in your application, and this is why you can't share memory just like that. This is why you need, for example, a mutex or an ARC. This is how you deal with shared memory. This is how you deal with references, and this comes in rather quickly. So I usually have one kind of workshop that runs for half a day or something, where we write a little chat. WebSockets-based chat. Yeah, so 50% of that is working with the Exum API. The other 50% is like figuring out what Rust needs from you. Why is a string different from a string slice? Why is a vector different from an array? Why do you need to have an ampersand here but not there? All those things. What's Tokio? What's asynchronous programming? Why do you need await stuff? And there's lots of potential, you can handle that in 3 hours. That's doable. Or you can expand and go into the nitty-gritty with each of those topics. The most important thing is that at the end of the day, at the end of the workshop, they have written some real software. Some software that they can use, they can deploy, distribute within the organization, or they can use as a template and as a prototype for their own services, for the things that they want to do. And this is something that I found to be much more fulfilling than going through, let's do our first hello world and let's see how I32 behaves if I add another I32 something like that.
Yeah.
Or I don't know how many times I've written struct person with name and age because that's just a nicer way of calling it foo or bar.
Yeah.
But having a little chat that runs over WebSockets, or working with APIs that do SQLX queries, something like that. That gives them some real world problems that they can solve with Rust, and that's always the best way you learn.
Yeah, that's a great way to do that. I think also sort of like my personal experience, sort of if you make the sort of initial hill you have to climb over until you can get to actually doing something too high, it's just demotivating, right? So yeah, you said sort of you can build like a simple chat server in Exum or so with people in half a day, but how much time does the average person need sort of to be comfortable enough with Rust to do more than that and also maybe without guidance then. So to reach some level of productivity where you can sort of actively contribute to something. Also maybe based on your experience at Dynatrace, right? Where I'm sure you onboarded people to that project as well.
So this is also a very interesting question because I have not one, but I guess 3 or 4 answers to that. It really depends on where you are right now. So when I started out, let's say it took me 2 months to really be confident enough to write programs that I would see finished enough to be run in a production environment at Dynatrace. Given the fact that Dynatrace is a huge company with lots of developers where, and obviously lots of clients where the software that you deploy there needs to run through a lot of quality gates to be actually published. So lots of stress tests, lots of quality tests, integration tests, whatever. I would have said 2 months, which is quite a long time if you're honest. So I was the first one at Dynatrace who developed Rust. And when we decided to do a Rust project together, I did workshops internally for them, let's say 3 to 4 days with actual software that they can use at the end of the day, and then go into additional guidance. And then people were able to contribute to a production code base in, let's say, a month or so, which was that trajectory. And the third one, which was even nicer, if you then have a couple of people who are already familiar in Rust and work on production code Rust, if you are able to take one person aside for 50% and let them guide the new team member, then you can have them productive in, let's say, 2 weeks or so. But it involves support. It involves guidance. If we are honest, every programming language kind of, or should have this approach where you have people guiding them through the production.
I mean, that's what we've been doing for years in other sort of ecosystems, right? Sort of be the experts to sort of work with clients' team and then guide them along the way and mentor them and then make everything easier for them, essentially.
And you know, Marco, this is the most honest way. So if we are honest to ourselves, it only works if you have people guiding you through that. It only works if you have sparring partners that you can tease with questions, who are willing to answer those questions. It just becomes so obvious when doing Rust, because Rust is a programming language that really requires of you to make decisions with every line of code that you write, which has syntax for every concept that you can imagine. Especially if you later go into the type system with writing traits with lots of trait bounds and associated types, where the syntax gets really, really complex, or where you work with async stuff where you need to box futures or pin projects or whatever. There's so many concepts there that are not unique to Rust, but never have been made so explicit with Rust. Then it becomes obvious that you need to have guidance there. And then timing is just a matter of how much you involve yourself or other people in that process. This is why I would say, okay, yeah, sure, Rust is a steep learning curve, but if you are true to yourself and if you're honest with yourself and you explicitly look for help, then you're just as fast as with any other programming language. It's just that you pay the price upfront for guidance, not later when everything breaks down and you need to figure out what went wrong. Because this is what I see a lot in TypeScript and JavaScript projects, where it seems so easy at first. And then along the line, half a year into the project, a year into the project, people develop with their best of intentions around a system that they don't fully understand. And then you get problems in the code base that are really, really hard to untangle, that are really, really hard to fix. And Rust won't allow you to do that. So you pay the price upfront, you still pay it. It's the same as in any other.
That also, sort of getting back to what you said before about your personal experience, sort of needing 2 months to build the first version. So I'm sure though that version went through all of the stress tests and so on. You mentioned easier and faster than, I don't know, an implementation in Java, JavaScript, whatever, right? Sort of that's the paying the price up front, but then sort of later it's going to be more stable, it's going to be safer and all that, right?
100%. So we always talk about the performance gains that you get when using Rust, but honestly, I much more look for the stability gains.
Mm-hmm. Yeah.
If you adhere to a couple of basic rules, which is, basically working with the result type and working with the option type as they are intended to be, then you write the most stable software in your life. Software that runs for ages, software that need little to no maintenance, software that doesn't show up in problem charts in your monitoring tool. So we monitor every bit and piece of our stack. Obviously, we are a monitoring company. Mm-hmm. Rust is not the problem. Rust rarely causes issues.
Yeah.
So this is immensely empowering. So having this trust in software that you've written. If I'm honest to myself, I just turned 30 last year. In all those years developing, I never had more confidence in my own software than when using Rust. In the early years, I had confidence in myself, but hey, I was young. Now I have actually confidence in the software that I produce.
And like you said, sort of you pay the cost either way, right? Either you pay the cost sort of while writing the software, right? Like, or sort of you pay it afterwards in the form of like bugs in your production app. Right?
Exactly.
And then fixing them and then getting back, fixing them is probably more costly than paying sort of a bit more upfront when writing the.
Definitely. And, there are studies out there showing that a bug introduced in the beginning and discovered much later costs so much. And when we talk technical debt, that's the price of technical debt. If you can avoid it up front, which you can to a certain degree with Rust, all the better.
I would like to close with one nice question. Sort of you teach a lot of people Rust, right? Sort of you're talking to a lot of people who are sort of new to Rust, learn it for the first time from you then. And I'm sure you get a lot of feedback from people in terms of what they love most about Rust, like what they discover during your workshop maybe about Rust. And then sort of they're super happy about having something that does that or so, right? Like, are there any 2-3 main things in Rust that people love the most?
One thing that really made me happy when I was doing a workshop in Berlin last year, somebody really shouted with excitement, with true and honest excitement. It's true. They have never written such a stable software in their entire life. You could see them glowing out of happiness, being excited of that fact. So this is definitely one thing. So knowing that you can have confidence in your code is a wonderful thing.
Yeah, not something people are used to necessarily also. Right?
Yeah. People love the error handling part. If you don't see error handling as something that goes into your way, but something that you can use to your advantage, like writing happy path programs, using error types or the result type just at the boundaries of your software, then you really say, I can write as if nothing would go wrong, but Rust still tells me when something goes wrong. This is something that people really enjoy about Rust, which is something that is now getting mimicked and copied into other programming languages through libraries or whatnot. Not in that way, but they everybody tries to grab this little feature and makes it their own because it's so fantastic. And obviously also what people really enjoy is that the speed at the end, that they have fast software that can do things much faster than their JavaScript or Ruby or Python equivalents, and at times even faster than the Java equivalents. So this is something that people really enjoy. So if you talk to upper management, then it's the cost savings, seriously. So this is also something that in the long run, people figure out that using Rust in production is cheaper for them than any other programming language. I know clients who moved all the AWS Lambda code from JavaScript to Rust, and the moment the Rust Lambda finishes executing, the Node.js Lambda just has booted up. There are huge cost savings in there, and you can always convince upper management if you put a $sign behind your investment. What's the return of investment there? And definitely. So I wouldn't write AWS Lambda without Rust anymore. It's just not efficient.
A great closing statement, I think. Like, don't do anything without Rust anymore. That's our advice, maybe. It has been great to have you. Thanks again for joining us. I'm looking forward to see you in Brussels at Eurorust, to mention that again, October 12 and 13 this year. Yeah, thanks again.
Thank you. Thank you so much for having me.